Hey there, boys and girls, ladies and gentlemen, damas y caballeros. Bienvenidos. Welcome to 8.3, Unit 8, Lesson 3 of Pre-Algebra. We're going to be talking about representing linear functions. I don't know why I decided to do grand and glorious welcome on this video. It just kind of happened. We just roll with the punches around here, even when there aren't any punches. We're going to be talking about, essentially, we're going to start graphing linear functions. We're going to represent them as a graph. We're going to do it a particular way. We're going to learn lots of different ways to look at graphing of functions. The nice thing about learning this method that we're going to talk about today in this video is it kind of always works. It works for linear functions and quadratic functions and cubic functions and quartic functions, and I'm going to end up going a long way down the rabbit trail. You can always graph a function by plotting points. Plotting points from that function. Let's see what we mean with an example. I think that's going to work out really, really well. So we are going to do example 1, and we are going to graph negative 2x plus y equals 4 by plotting points. And we're actually going to make 2 of those points that we plot. We're going to plot 3 different points at least, and we're going to make 2 of them the intercepts. Excuse me. So what are we talking about when we're talking about intercepts? Intercepts. There are 2. I was about to write 2. And yeah. Anyway, what are the intercepts? Well, we're talking about the Y-intercept. We're talking about where the graph crosses the Y-axis. The Y-intercept. And we're talking about the X-intercept, which is where the graph crosses the X-axis, the X-intercept. Now, in order to figure out where they are in the function that we're going to be graphing, we need to think about what x and y are equal to at those intercepts. By the way, on these, if you're one of my students especially, if you're not one of my students, then thanks for joining us. Like, comment, subscribe, all those things would be wonderful. Use a straight edge when you're doing graphing, always, for the axes and the lines both. I don't want to see these little lines like this. This is stupid looking. Don't do it. It takes half a second to grab something straight and draw a line. It's going to make your work look better. It's going to make your teacher understand it better, whether I'm your teacher or somebody else is, and whatever else. Okay, so do the thing. Use the straight edge. So back to rabbit trail is over. Back to intercepts. So all the way along the y-axis, what is x equal to? Well, we didn't move to the right any or to the left any. And so if we didn't move anywhere, then all the way along the y-axis, x is equal to 0. So let's start plotting some points here. I'm going to go back to pink because we're going to graph this one in pink. We'll do the next one in green or yellow or something. All right. So let's start by plotting points. To plot points, we're going to make us a table. All right. Basically a table of points. We're going to do at least 3 points. Okay. So the first one we're going to do is going to be the Y-intercept. Y-intercept. All along here, x is equal to 0. So to find the y-intercept, what we're going to do is we're going to plug a 0 in for x and solve for y. So we're going to do negative 2 times 0 plus y equals 4. Now we need to solve for y. So to solve for y, we're going to start with cleanup. This time 0 is nothing. Oh, wait, cleanup was really easy on that one. That was like super simple, almost too easy. That just goes away. leaving us with y equals 4. So when x is 0, y is 4. Let's go ahead and go over here and plot that point on this graph. So when x is 0, y is 4. So the first point we're going to put on there is right here. Okay. Then the next point we're going to plot is, it's fine. The next point we're going to plot is the X intercept. Now, all along the x-axis, we have the same sort of concept. All along the x-axis, y is equal to 0. So to find the x-intercept, we put a 0 in for y and solve for x. I think I'm going to make my brush a little smaller. Okay, so we're going to do -2 times x plus, we're going to put a 0 in for y, and then equals 4. I'm just copying this equation, but with zeros in for the places, right? So this first bit is going to cancel out, leaving us with -2x equals 4. How is that -2 attached to x? Well, it's multiplied, so how do we get rid of it? We divide. So we're going to divide both sides by -2. -2 and -2. And so these ones cancel, leaving us with x equals -2. So that tells us that the x-intercept is -2 for the x part and 0 for the y part. Okay, easy peasy lemon squeezy. So let's plot that point. We're going to go -2 on the x and up and down 0. So there it is. That's actually technically enough to graph that thing. Let's go the same distance though and plot one more point. I'm going to do the work over here. I think that'll be neat enough to make it work. So I'm going to plot, instead of -2, I'm going to plug in +2 and see what y turns out to be. So same substitution steps, same sort of plan. We're going to do -2, and we're going to put parentheses where the x is. We're going to bring everything else down. Again. We are just copying this equation, substituting 2 in for x, right? So we're going to put a 2 right there. Now we're going to solve for y. We've got a little bit of a cleanup step. -2 times 2 is -4. Bring down plus y equals 4. We're going to this 4 here. This is subtracted from y because adding a negative is the same as subtracting, right? And again, if you're trying to remember whether you add or subtract, you want to do whichever one is going to get rid of this number. If we were to do -4 minus 4, that would be -8, not 0, like we want it to be. So we're adding 4 to both sides. These cancel, leaving us with y equals 8. So we're going to plot the point 2, 8. 2, 8. There we go. So we're going to go over here and go over 1, 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. Plot a point. Now all we have to do is connect the dots, and we've got a line. Mine, I have to kind of do it in phases if I want to, because that's how my straight edge works. You should be able to just, scribe your line. But my straight edge is shift key, connecting dots. So that's what works for me. We like to put arrows at the end representing that this is a line and not a line segment, and it goes forever and ever. Work out fairly well? Yes, in fact, it does. Let's do one more example. We're going to do this one a little bit differently. This time, instead of doing the y-intercepts, we're just going to plot 3 random points. One of them will be the x-intercept, the y-intercept. So we're going to do the same thing, but we're going to graph. Let's see, where's the one I want to do? There it is. This is example 2. We're going to graph 2x plus y equals 9. So we're going to plot 3 points again. We're going to stick those points on, connect the dots, and then we've got a line. So we're going to pick, let's do this in green. I think that's what I said, right? X, Y. We're going to do -1, 0, 1. That sounds good. That'll give us kind of a indicator there. So we're going to plug in -1 for x. So we're going to put parentheses where the variable is that we're substituting for and bring everything else down. We're going to put a -1 in there. 2 times -1 is -2 plus y equals 9. To get rid of this -2, of course, we will add 2, just kind of like that last thing we did over there. +2, +2. Well, this point's going to be off my little grid that I've got going over here because I've only got plus or minus 8, but that's okay. Equals 11. So the first point we're going to plot is -1, 11. And then the next, I can't get there, so I may have to kind of mess around a little bit. We'll see what else we get and figure out what's happening, and then maybe we can decide what other points we want to graph to get something that's going to fit, right? So we're going to plug 0 in there, right? So we're going to put 2 times 0, that's always a nice one, plus y equals 9. So this cancels out. So we end up with y equals 9, which is also above my graph. It's going to be like up here, right? Right up in here. So what that's telling me is that we're going down, right? We're kind of dropping down lower. So let's do a handful more. I can fit them over here, right? I'm going to do 2, 3, and 4. And I think that's going to get us plenty of points to plot. We already did that. We just did this one. This one's 9. And I'm going to go ahead and just not do this one just to save ourselves some time because I said we want to have at least 3, and this is at least 3, right? So let's do 2. We're going to plug a 2 in there. A note on doing things with lines on your paper, like what I'm doing here, where I'm separating steps and problems with lines. You notice that it's still really neat. If you're doing problem, steps, and then you're doing boxes like this, and then you're doing another problem, and then maybe a half step, and then doing boxes like that, that's not neat and organized and orderly. If you're gonna separate your problems with lines, it has to still be neat, right? So that's the name of the game, right? Neatness is going to help us make less mistakes. So 2 times 2 plus y equals 9. 2 times 2 is 4 plus y equals 9. We're going to subtract that 4 off because that's what would get rid of it. Minus, having trouble drawing a straight line at the bottom of my screen here. -4, -4. Those cancel, leaving us with y equals 5. Now that point we can fit. So let's go ahead and plot that one. I'm going to do it in this nice vibrant green. Over 2, up 1, 2, 3, 4, 5. So there we go. There's our first point. Let's come over here and do 3. 2 times plus y equals 9. We're going to plug a 3 in. 2 times 3 is 6. And then we bring down plus y equals 9. We're going to subtract that 6 off. I don't know why I decided to make this so gigantic. I think I can still fit another one right next to it, and it's going to be okay. Or actually, I can probably fit it up here because it's looking like we're not going to have graph over there, so it'll be all right. I'm kind of limited on my space trying to keep a problem on a single screen. That's one of the only reasons why I tend to squeeze stuff together sometimes. It's not that it's more of a, because of the medium that I'm working in. I'm going to put a 3 here. It's a little bit of a do as I say, not as I do, and I apologize for that. I don't like doing that kind of thing, but we're going to go over 3 and up 3 and plot a point, but it's kind of where we are, right? It's kind of the best we can do with keeping the problem on one screen. So let's do the last point. We're going to put a 4 in there. So 2 times plus y equals 9. We're going to put a 4 in there. 2 times 4 is 8. We're going to bring down plus y equals 9. Got to subtract that 8 off of there. Those cancel, leaving us with y equals 1. So we're going to put a 1 in our table, and then we're going to plot that point by going over 4, up 1. Then we connect our dots, and we've got a graph ready to go. Is that right? Yep, that's right. Beautiful. Did I do one wrong earlier? Is that 0 actually 9, or is it 8? 1, 2, 3, 4, 5, 6, 7, 8. Oh, no, that's right. Yeah, that's totally right. From here to the air. Whoop. Oh, how about to there? There we go. Yeah, that's beautiful, and it comes something like that. Perfect. Again, limits of technology. My straight edge isn't as handy as yours. So there is our graph, and that nice, beautiful acid green color. We love it. Watch out, Ninja Turtles. We can graph lines. We will see you in the next video where we will talk about rate of change. We're going to start heading towards slope and all of those things, and things that are going to be really cool and important all the way through calculus. It's going to be lovely. Can't wait to see you there. If you're one of my students, I'll see you in class. If you're not one of my students, thanks for joining us. If all of these videos for this pre-algebra course and our Algebra 1 course are available for free here on YouTube, thanks for joining us for these lessons and all the things. A like and maybe a comment or two and a subscribe would be wonderful. Thanks, guys. Have a great day. Bye-bye.